everybody. We are starting off Unit 3 with solving linear systems by graphing. So we are actually going to go ahead and use our warm-up as a little bit of review from our last unit on graphing lines. So it says graph the line given by the equation. We have 3x minus 2y equals 10. So normally with standard form, I would want to find my intercepts, right, by plugging in 0 for x and for y. But in this particular equation, I can see that it equals 10. So when I try to find that x-intercept, I'm going to get a fraction, right? Because 10 is not divisible by 3. So let's go ahead and put this into slope-intercept form so that we can graph it. And we'll do that by first subtracting 3x so that we can bring it over to the other side. And I'm always going to put it after the equals. And our last step is that we are going to divide by -2. And then we get that y is equal to 3 over 2x minus 5. So let's go ahead and start by graphing our y-intercept at -5. And then we will go up 3 and over 2. Up 3 over 2. And I can use my line tool and make sure my line is nice and through all my points. I'll make it purple so it matches. And I put my arrows on the ends. So there is the line. And it asks me what's one solution. So remember, solutions are points on our line. So I graphed 3 points. I could use any of those. This is a solution, this is a solution, and this is a solution. So our first solution is 0, -4, right? Our y-intercept. The other one that I had is 2, -2. And the third one that I graphed was 4, 1. So there are 3 solutions to the graph. So anything on that line could be a solution. So a system of equations. So a system of equations is 2 or more linear equations with 2 or more variables solved at the same time. Sorry, I didn't mean to say 2 or more. We'll say with 2 variables solved at the same time. The solutions to a system of equations are values that make both equations true. So here we have been given an actual system. We have -5x plus y equals 0 and 5x plus y equals 10. So we have to start by putting these into slope-intercept form so that we can graph them. So for this one, all I would have to do is add 5x to get that y equals 5x, which means that my y-intercept is actually just at 0. I'm going to go up 5, 1, 2, 3, and over 1. Up 5, over 1. And we can graph that line. My other line, I'm going to actually subtract 5x to put it in slope-intercept form. So I get y equals -5x plus 10. I start at 10 for my y-intercept, and I go down 5 over 1. And I draw my line. So, I mean, it's kind of hard to tell because my lines aren't super straight, but I can see that those 2 points, or those 2 lines, are sharing a point, right? So if a point is a solution to a line where both lines share the same solution, is going to be their common solution or a solution to the system. So the solution for this system is 1, 5. I go over 1 and up 5, and that is where they intersect. So I'm actually going to go back here to where I said we're a solution of system of equations. I said values that make both equations true, where the lines intersect. So when we're graphing, it's going to be where both our lines intersect, right? Let's go ahead and practice this again. So I have x minus 3 equals y. So this is already in slope-intercept form. It's just backwards. I can rewrite it. Y equals x minus 3. Same thing. Okay, so if you see it like that, don't get confused. Your y is just coming at the end. It's still already in slope-intercept form. So let's go down 3. And our slope is 1 over 1. Up 1 over 1, up 1 over 1. Okay. Our other line starts at positive 3. Looks like we go down 2 over 1. Down 2 over 1. Oh, and there is my common solution. So the solution to this graph is 2, negative 1. Okay. Y equals x minus 3. So let's go ahead and graph that. I'm going to go down 3. Up 1 over 1. Oh, we graphed the same equation in our last problem. No problem. Okay, let's go ahead and put that down. Our second graph, however, we need to divide by 2 to get y alone, to get y equals x minus 3. So as I'm graphing this, I can see that they're the exact same line, right? I ended up with the same equation for both. So what kind of solution would we say? Well, they're sharing every single solution. I'm going to say this is an infinite solutions. I don't know why that T looks like that. All right, infinite solutions. So we have the graph of the same line. They have the same slope. They have the same y-intercept. Infinite solutions. All right, so let's start with x plus 3. So we're going to go up 3, up 1 over 1. Draw our line. X minus 3, we go down 3. Put our y-intercept. Slope is still up 1 over 1. Draw our line. Okay, oh, I don't know why the line looked like that. All right, so as I see here, my lines actually do not intersect, and they're going to follow this slope on and on and on forever, and they're actually never going to intersect. So lines with the same slope are parallel. We say no solution. So one solution, x comma y. And this x comma y is just the solution, right? The ordered pair at where they cross. These have a different slope and a same or different y-intercept. Their intercept can be the same, doesn't have to be. Infinite solutions, however, have the same slope and they have the same y-intercept. So they're exactly the same for both. A no solution has the same slope so that they become parallel. But they have different y-intercepts. So that they actually do not ever cross. And that is it for solving systems by graphing. Okay. Oh, just kidding. We have one more problem. So now that we kind of know using all of these different things about a one solution, infinite, and no solution, what values of A and B would make this system have no solution. So no solution, remember, is parallel, meaning that they're going to have the same slope. So A would have to be 3 so that the slope would be the same. B would be anything but 2. So that way they never actually intersect. What would make them have infinite solutions is just to make them the exact same. So A would have to be 3 and B would have to be 2. So now it's the exact same line for both. So that's it for today and graphing systems of equations and finding their solutions. So the solution is where the lines intersect, where both equations become true. One solution is where they intersect, they have different slopes or different same y-intercepts, infinite, same overlapping lines, same slope, same y-intercept, and then no solution are parallel lines, same slope, different y-intercept.